Representing data, example 10. In this question, we're talking about a restaurant owner who's analysing the waiting times of the customers in his restaurant. He's done this for 20 customers, rounded it to the nearest minute. The first part is to find the median and the interquartile range of the waiting times. So, usual approach, work out n over 2. There are 20, so it's 20 over 2, which is 10. Now, if you remember, when it's an integer, we work out the 10th plus the 11th, add them together and half it. I'll give you a minute to pause the video and put those items of data in order of size, and then you can tell me what the 10th and the 11th are. So if you've put them in order, you probably have worked out by now that the 10th and the 11th are both 16 when you put the data in order. So if you add them together and half it, your answer is 16 for the median. The lower quartile, n over 4. So we've got 20 over 4, which is the 5th. So again, we're going to look for the 5th and the 6th, add them together and half it. And if you've got them in order, you will see that both of those are 15. So when you add them together and half it, you're still going to get an answer of 15. Q3, 3n over 4. And if you work out 3 times 20 divided by 4, you get the 15th. So we want the 15th, add the 16th, half it. And here they are different. The 15th one, if you count through your list, is 16. And the 16th one is 17. Slightly confusing there. So when you add them together and half it, you get 16.5. So nice, easy 5 marks to start with. We're then asked to look at whether there are any outliers that fall 1.5 times the interquartile range above the upper quartile or below the lower quartile. So we'll do that next. So Q1 minus 1.5 times the interquartile range. Let's see what we get there. So that will be Q1, 15, minus 1.5 times Q3 minus Q1. And if you work that out, that's 12.75. Now, looking through the original data, there's nothing lower than 12.75. So there are no outliers at that lower end. If we now do the upper end, Q3 plus 1.5 times the interquartile range, we're going to get 16.5 for the upper quartile plus 1.5 times Q3 minus Q1. So that's 16.5 minus 15. And if you work that out, that's 18.75. Have we got any outliers at the upper end? Well, we've got one outlier. 25 is an outlier because it's above the upper outlier boundary. Draw a box plot to represent these data, indicating any outliers. Okay, so I think the lowest item of data was 14. So I'll just quickly label the scale. You draw in a straight line here along the bottom for the scale, and then we've got 25 as an outlier. So I'll just go a little bit past that. Okay, so lowest value, if you look back at the data, was 14. The highest value was 25, that was an outlier. The next highest after 25 was 18. So if you know the actual value, you can put that on. If you didn't know the actual value, you'd use 18.75. You'd use the upper boundary for outliers, but we actually know the data. Our median was 16, if I remember correctly. The upper quartile is 16.5, so the data is very closely grouped there, and the lower quartile was 15. So using a ruler, I join up the box, put on the whiskers, and that's what it should look like. And this is the number of minutes. Make sure you use your ruler for that. So that's again another 7 easy marks. Find the mean of the data. Well, you just add up all the items of data and divide by how many there are. If you add them up, you should get 322. Divide by 20. So the mean is 16.1. It then says comment on the skewness of the data and justify your answer. Now this is where you're getting into the A grade marks in the sense that it's only really the A and B grade candidates that manage to fully justify their answers on questions like this. So there's two ways to look at it. You can either use that rule for outliers where you compare the quartiles. So we'll do that one first. Q3 minus Q2 in this case is 0.5. Q2 minus Q1 in this case is 1. And so we see that the upper part of the box is smaller than the lower part of the box, and if you consult your notes, that means that we have a negative skew. And actually you can see that from the diagram. You can see that this part is more spaced out and then it's more clustered together at the top. Don't be too misled by the whiskers. It's this central 50% we're interested in. So you can see that it's more spread out on the left hand side and more clustered on the right hand side. So it's got a slight negative skew there. The alternative is to compare the mean and the median. So again, looking in your notes, the mean is 16.1, the median is 16. And so because the mean is bigger than the median, we would say that we've got a negative skew. In both cases, it's very close. So I would say it's only a very slight negative skew. And again, the diagram backs that up.